Now we're going to be looking at a bunch of things about functions. I'm going to start off this way. So a function is a block of code that is designed to do one specific job. So that's the way functions are set up. Their goal, why you use them, is to help accomplish specific tasks. And that's how we use functions. And they are helpful when you want to perform a particular task several times. So, and all you need to do is write the code and then make a call to that one code that you have. Now it localizes the program and makes it possible for you to just go to one program, tweak that program, and everywhere that a call has been made would be affected by those changes. So essentially, using functions can make your program easier to write, read, test, and then fix. So this is an example of a function that is called, that has a name, greet user. Def, which is the def that you see here, is essentially the function definition, right? It's a keyword that's used to let Python know that you're about to define a function. Once Python sees def, it just knows, hey, get ready, we're about to define a function. And then the next thing we have here is what you would refer to as the function name, right? Greet user, for example, is a function name. And then notice the other thing about a function is that it closes out with a colon. Now, the next thing you see here is what we refer to as a doc string, right? It's essentially a comment. You can see 3 quotation marks on both sides of that comment. Now, that is not, think of it like your typical comment in your program. So what happens is, especially if you want to, the Python wants to compile the documentation for this particular code. Once it sees this, it's able to help you describe what that program is about. And this is actually where you put in that description, right? So they say typically includes in this 3 quotation marks. And whenever Python wants to generate a documentation for this code, what it does go to look for, it will go look for those 3 quotation marks, open and close, and that's how it knows it's a doc string. And the whole purpose of the doc string is to help describe exactly what that program is about. And then the next thing you have there is this. Now we have print hello, but it could be any kind of instruction, right? Could be anything that you want to be done. That's where, which is like the body of the function. In this particular case, all we just wanted to do is, hey, ask it to print hello. Now, in other functions, when you come into this parentheses here after the name, right, you have what we call parameters, right? That's additional information that the program needs to run. But in this particular case, it's empty, right, for users. So that information does not exist, which is not strange, right? But when it does exist, what it does is it holds the information or the parameters that this particular function needs to do its work. So eventually, as we go down, you're going to see specific examples of functions that have parameters. And then we're going to talk about parameters and we'll talk about arguments. Now, the whole of what you have here is referred to as your function. But then each time I want to invoke this function to get it to do what it is designed to do, all I need to do is go use the function name, which is this, and just call it. Drop it somewhere there, make the call, and then all of a sudden, everything that is here would happen because we called this. So think of this like the engine of a car, and then think of this like the accelerator that you tap, right? Once you tap the accelerator, it will bring all the power that is available here. So now all the instruction, this function that has been created, which is, by the way, is a user defined function, all it does, right, is to print hello. So now we have, if I run this, cell not, what input do I have? Let me stop. There's something that needs to be done. Just 1 minute. Let me go, or let me refresh this code so that it restarts completely. So here, I can now, is it still busy? Let me interrupt the kernel. Okay, let's try to run it again. So we run it, and this is what we have. Again, this is our function. We made a function call, and then this is what we have. Hello, it says hello. So if I wanted it to do something different, I could say hello. It's a sunny day. Yeah, I love it, right? Then once I run it, it does the same thing because that's what this function does, and that's all it is about. So next thing, and that's a particular case of a function call. Now let's look at a completely different scenario. And what is this scenario all about? Now we are trying to pass information to a function, right? So how do you pass information to a function? That's where the parameters and the arguments that I referred to in the past become very important. So look at a function like this. Unlike the first function, we had a situation where this parenthesis was empty. And when you made the call here, this was also empty. Let me go back so you can refresh your memory. Empty, empty. But in this particular case, we don't want it to be empty. We actually want to pass information to the function to do specific things. And eventually, as we proceed in the study, I'm going to show you different ways, right, of passing information to a function. Now, what you have up here, again, remember that all of this is the function. This is the call. So when we come to the function, right, we have a function name. This is a function definition, a function name. Now, in the parentheses that exists, you might have one or more, elements within the parentheses. Those elements, right, are referred to as parameters. They are referred to as parameters. And I can pass information from this function call into that function by having what we refer to as an argument. Typically, when I make a function call like this to this function, it passes this argument, right, and maps it to the parameter and does what I want it to do. So you can notice that the complexity of the function is beginning to grow from an empty parenthesis now to a parenthesis that holds some kind of value. And I said on the function side, what's in that parenthesis I refer to as parameters. And on the call side, what's within that parameter, what's within the parentheses are referred to as arguments. So look at this example. So I have my definition, function definition, function name, and then my parameter, and then my doc string, right? Then after that, this is the specific instruction I want it to do. So I'm using an F string and I say hello, and then I look at my username, right? What's my username? That's the parenthesis, dot title. Now I'm using another method, right? And the idea is to make it a proper noun, right? And then if I run this, right, I want to call this. All I need to do is go say greet user, and I can put in any word here. Once I put in any word here, it will map to the username so that anywhere you have user name, it will essentially return whatever it is that you have here. So in this particular case, we have JC. So I run this and then we have JC. What if I decide that I'm going to put Philip here? Right? All of a sudden, it's going to map this argument to this parameter, and then it will give me that value. So hello, Philip, right? Why is that happening? Because this is the instruction. So I would continue, and let's talk some more about arguments and parameters, which I already have kind of alluded to. So the important thing to notice here is that within your function, the parentheses that you have there is going to be your parameter, and then in the function name that you use for your call, what you have there is an argument, and that argument maps to the parameter, and that's how you get things like done. So essentially, the argument is passed to the function, and then the value is now assigned to that parameter. So now notice that people sometimes speak of arguments and parameters interchangeably. They mean them to be the same thing, right? So the point is, don't be surprised if you see variables in a function definition referred to as arguments, or the variables in a function call referred to as parameters. But for the specifics in this particular course, we'll prefer to refer to what you have on the function side to be the parameter, and what you have on the call side to be the argument. It keeps everything very clean. Now, there are so many types of arguments, right? And you have to learn how to pass these arguments back and forth to do specific things. So as you would see, as we go through this, there are different kinds of arguments. There's one called the positional argument, and then you have the keyword argument, different kinds of arguments. So I'm just going to go through. Let's walk through the different kinds of arguments that we have. You know, keyword argument, and then there is I'm rushing to see the other. Let's just focus on those two for now, because there are different kinds of arguments. But in positional arguments, the thing about positional arguments is like the position of the argument matters, right? How you position them. So let me show you an example of what I mean. So in this particular function, you go down this way, right? This is a function, and here's your function call. Now you have two, now it's no longer one parameter. You now have two parameters: animal type and pet name. Now, for your argument, you have hamster and Harry. For positional arguments, the way you arrange this matters a lot. It's not necessarily, order does not necessarily matter as much in other cases, but if they are positional arguments, then it's really, really important how those arguments are arranged. So for the purposes of this, it says when you call a function, Python must match each argument. Each argument, what arguments are they referring to? Animal type and pet name with a parameter in the function definition, right? So Python, sorry, Python must match each argument. These are our arguments, right? So it must match each of these arguments to the parameter here. So in other words, if this is position 1 and this is position 2, when you're mapping this to this is going to be 1 and this is going to be 2. So values matched up this way are called positional arguments. To see how this works, consider a function that displays information about pets. The function tells us what kind of animal each pet is and the pet's name as shown here. So this is what this function does. All it does is to describe pets, and when you choose your function name, you have to try as much as possible to make it as descriptive as possible so that whenever anybody sees it, it's also even good for yourself, the programmer, so that when anybody sees it, whether yourself or the programmer or any other person, once they see it, they can almost immediately tell what that function does. Once you see print as a function, you already know that it has something to do with printing something, right? So in this particular case, the function name is describe pet. And then you have your docstring, which is important. This is how Python compiles the documentation for this program. When it comes here and it sees these 3 quotation marks, open and close, it picks up whatever is there to help describe what this program does. Now this program has 2 lines that need to be executed, and they are both print functions, right? And this says, remember your F string, right? So use an F string to write out this comment, but the /n here just says go to a new line, and it says I have a curly braces animal type. What is my animal type? That's my parameter. Then the second line says my animal type's name is, then the pet name, which is the second parameter, dot title, so that we'll make the pet name a proper noun, and that's it. So describe, and then I make a call. When I make this call, I include hamster and Harry, and then you would have this. It runs the first line, which is I have a hamster, and then the second thing is my hamster's name is Harry, right? So let's try something else. Let's have another line of code, and let me say something else, because this is going to be a little weird. So I say something like, I have a hamster. So this is, we're going to make this go well. I have a dog, and my dog's name is Bingo, right? So I run that. So I have a hamster. My hamster's name is Harry. I have a dog. My dog's name is Bingo. What if I decide to change their positions right now, right? Be like, let me just randomly put Bingo here, and then I put dog there, right? Then we will have an awkward situation. I have a bingo, my bingo's name is dog. All of a sudden, it's gone gaga. So the position of the parameters, as it were, is really important, and that's the point I was trying to communicate here. You can also do multiple function calls. You can call a function as many times as needed. We've already done a bit of that here, right? So I'm not going to bedevil this. So calling a function multiple times is a very efficient way to work, right? So with that one line of code, I can, all through my code, I can make multiple function calls, all over the place, and everything would be fine. And I just have a central place where it picks up all of that information. So the code describing a pet is written once in the function. Then anytime you want to describe a new pet, you call the function and all of that. So I already described the part about the order mattering in a positional argument, right? If you switch the order, then it begins to say something that does not make sense. So the next one that we have to look at here is what we now refer to, just 1 minute. Sorry, I was looking for the positional argument that we talked about. Just not, yeah, this is it. Yeah, so this is our positional argument. And then I want to go to the next one, which is keyword arguments, right? This is our 2, I believe. So these are keyword arguments. And this is a little interesting and kind of different. Now look at this. A keyword argument is a name value pair. Remember, in dictionaries, we said something is a key value pair. This is kind of something along those lines, but just pay attention to see how that works. That you pass to a function, right? So you directly associate the name and the value within the argument so that when you pass the argument to the function, there is no confusion. So essentially, you will do all of that, and you set it up in such a way that you can create any kind of order, but in the midst of um, that, you can rearrange it in whatever way you want to arrange it. But guess what? You would have already mapped the name and the value within it, and you're going to see a specific example. So let's look at this particular example. So look at this. You directly associate the name and the value within the argument, so you can pass the argument to the function. There's no confusion, so you wouldn't end up with a Harry named hamster or a bingo named dog, right? So keyword arguments free you from having to worry about correctly ordering your argument in the function call, and they clarify the role of each value within the function call. So if we were to rewrite the previous code, right, here, notice what has changed now, right? Now we map, this is our parameter. So I just come in here and say, okay, my parameter animal type is equals to this, and my pet type is equals to this. So there's no confusion. Even if I change the order of this to this point and move this to this side, it does not matter. It will still do what it's supposed to do, right? So that's exactly what you refer to as your keyword argument, right? So this is what we have. So notice here, right? If you now decide to do a call where, notice the order, animal type hamster, pet name Harry. If you go switch it and move this to this point and bring this to this side in the second line, both of them are still going to give you the same result, which is what you're seeing here. So, but the thing with keyword arguments is that when you use them, you need to use the exact names of the parameters in the function definition. In other words, whatever your parameters are, you have to use those exact things in your function. This makes it very safe that you don't mix up things with the specific order. So you also have times when you might have to, define a default value for each parameter, right? So let's look at a specific example here. So it says when writing a function, you must define a default value for each parameter. Now, if an the argument for a parameter is provided in the function call, Python uses the argument value. If not, it uses the parameter default value so that when you define the default value for a parameter, you can exclude the corresponding argument you would usually write in the function call, right? And I'm going to explain what all of this is. So using default values can simplify your function calls and clarify the ways in which your function are typically used. For example, notice this. If you notice that most of the calls to describe, your described pet are being used to describe dogs, you can set the default value of animal type to dog. Now, anyone calling describe pet for a dog can omit that information. So essentially, um, a lot of things when in programs, right? You find a situation where a default value is set. In other words, if you do not do anything otherwise, we are going to use that specific default value. And what it talks about in this particular case is, since we are trying to describe pets, but maybe most people that are interacting with this application, when they are trying to describe a pet, most of them, maybe 80% of the time, it's a dog. So I don't want to give them the additional burden of having to create the argument dog. So I just create a default value. And the way I create the default is I have my pet name here. I don't default it. But for my animal type, I can create a default. And my default is dog, right? So if this person comes in here and just types just pet name without giving the animal type, all of a sudden it still works out, right? So I run it, right? So, but how about if I don't want to use the default value, right? I could come in here and then I would say something like this, right? And I will be like horse. Even though this is the default value, dog, notice what happens. Now it says I have a horse. My horse's name is Willie, right? But dog doesn't feature anywhere at all. But anytime I do not have anything there, the system automatically defaults to dog, right? That's the function or the behavior of default values, right? When you're writing functions. Okay, so we're going to look at something else, right? um, I wouldn't consider this a specific type of argument. So equivalent function call, because positional arguments, keyword arguments, and default values can all be used together. There are several equivalent ways to call a function. Now consider the following definition for describe pets with one default value provided. Right. So let's go. With this definition, right? An argument always needs to be provided for pet name, and the value can be provided using a positional or keyword format. Now, if the animal being described is not a dog, an argument for animal type must be included in the call, And this argument can also be specified using the positional keyword format. All of the following calls would work for the function. So let's zero in on this particular part, right? So we have these parameters: pet name, animal type. Obviously, we are using the default here, right? So for animal type, the default is dog. And then we have our dog string. And then we have our two instructions, right? To run this. So if I use this, I run this, describe pets, and I just use Willy, right? Automatically, pet name will be mapped to Willy, right? Describe pet. So this here is positional argument, right? It will do the same thing like a positional, a keyword argument will do, right? Same thing, no difference. But the thing is that the second part exactly maps it to, there's no confusion here, right? Then let's look at this. Describe Harry and hamster, right? It maps it to this, and this maps it to this. Same thing. This is your positional, an example of your positional argument. The second is an example of your keyword argument because you're locking it in, you're mapping the parameters to the arguments, parameters to the arguments. But look at this too, right? Animal type. This is animal type. And then pets. So if we run all of this, this is what we get, right? I have a hamster. My hamster's name is Harry. So in this particular code, all of these three, right, are used: positional arguments, keyword arguments, and default values, and it all works out. So you can use any number of them, but obviously you can see there are advantages and disadvantages to each one of those. So one of the things you want to make sure, you know, is that you avoid argument errors, and argument errors can happen, right? And that's why for some time it might be better for you to use um, a particular type. So positional arguments can be more prone to errors. So it says when you start to use functions, don't be surprised if you encounter errors about unmatched arguments. Unmatched arguments occur when you provide fewer or more arguments. So for example, if I have three parameters here, maybe two parameters, three arguments, chances are that I would get an error. So you have to, those are some of the kind of things that you need to. So notice here, you're not providing any information, right? No animal type, no pet name. And unfortunately, we also did not create a default. So because we don't have what it needs, it throws up an error. It has more than what we need, it throws up an error. So all of those are possibilities. And when you see it, and you can see it here, fail string C, it can show you where the error is coming from because it can't find what it needs to do its work. So that's important. Let me comment this out and then we proceed. So it says, Python recognizes that some information is missing from the function call, and the trackback tells us that. So we can see that some information right there is missing. So this is an assignment you can try to do. So we're going to look at return values too. A function doesn't always have to display its original, display its output directly. Instead, it can process some data and then return a value or set of values. So it doesn't have to essentially output anything directly, right? The value of the function return is called a return value. The return statement takes a value from inside a function and sends it back to the line that calls the function, right? So every time it's not about printing something, like you can grab some information and send it somewhere else. So returning a simple value. So let's look at a typical example. I'm saying here, I have a function called get formatted name. I get the first name, I get the last name. So the full name is going to be the first name and the last name. And then my return is going to be full name dot title. So that's what I return, you know. So I have something here and I'm like, okay, musician, that's a variable, and I map it to my function name. And then I enter Jim and Hendrik. And then I print this out and then it returns this for me. So this is a return value. It takes a first name, takes a last name, and neatly formats it and returns something. So you can also have a return value of sort, just like this. Remember, everything we've been doing before was print, 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 but we can actually return, use, so the return values allow you to move much of your program grunt work into functions, which can simplify the body of your program. Or another way to look at it is the return statement, right? Which is this return takes a value from inside a function. In this particular case, it took first name and last name and sends it back to the line that called the function, right? That's what it does. So in some cases, you can actually make an argument. You can make an argument optional, right? The fact is, how do you now make that argument functional? So let's look at it. Sometimes it makes sense to make an argument optional so that people using the function can choose to provide extra information only if you want them to. So you can use default values to make an argument optional. And we saw a bit of that, right? Where we mapped a particular thing. But let's see how this works here. For example, say you want to expand, this particular function, get formatted name, to handle middle names as well. So you have your first name, last name, and your middle name, but you want it to also deal with username. So you include first name, middle name, last name. So these are your parameters, right? And what you're trying to do with this function is to return a full name neatly formatted. So we go for our first name, our full name, first name, middle name, last name, and then your return name is full name dot title. We just did the return statement. Now we can say musician is equals to get formatted John Lee Hooker, right? And then we print, and then you get John Lee Hooker. Now, notice here, the middle name aren't always needed, right? And the above function as written will not work if we try to call it with only a first and last name, because in this particular case, we used three parameters which map neatly to three arguments, or sorry, three arguments which map neatly to three parameters. So if we give it just two names, right, we are going to get an error, right? So middle names aren't always needed. In a case where we don't need a middle name, right, how do we modify this program, or what do we do to this program so that it doesn't throw up an error if we just give it two names? To make the middle name optional, we can give the middle name argument an empty default value and ignore the argument unless the user provides a value. So that's how we modify the program, right? So when we come in here, how do I do that? We'll create an empty default value. So we have first name, last name, middle name. And this is how you create an empty default value. You say equals to, open and close bracket, and don't put anything in there. Right? And that's how you do that. So, and this is the specific instruction here. It says if middle name, right, full name is equals to first name, middle name, last name. So if we have, if it says if we have a middle name, then make full name, first name, middle name, last name. Else, if there is no middle name, then just make it first name and last name, and then return the full name. And the full name could be this, which is all three names, or it could be this. But it's predicated on the condition that I get a middle name. But if I don't get a middle name, right, then just make it such that it's going to be first name and last name. So look at a particular situation where I say musician is equals to function name is equals to Jim and Hendrik. If you run this, it will give you Jim Hendricks. If you run a different scenario where this person provides, in other words, it meets the first condition, then it would print out the three names. So calling this function with a first and last name is straightforward. If we are using a middle name, however, we have to make sure that the middle name is the last argument passed so that Python will catch up with the positional arguments correctly. Optional values allow functions to handle a wide range of use cases while letting function calls remain as simple as possible. So that essentially shows how you handle that. So what else do we have? And now you were talking about, I know you mentioned returning a dictionary, right? So this is a typical example of you trying to, return a dictionary within a function, right? A function can return any type of value you want it to, including more complicated data structures like lists and dictionaries. We haven't done lists and dictionaries in the context of functions, and here it is right now. For example, the following function takes in part of a name and returns a dictionary representing a person. So this is what we have, right? We've created this function build person. They have their first name and their last name, right, as parameters. The goal of this entire program is to return a dictionary of information about a particular person. So this person, right, is equals to first name, which is equals to the first name here, last name, which is equals to the last name. So we have kind of started creating that person. And what you have here is our dictionary, right? That says um, this person, this is your value, key value, and then I return person. That's what I want to do. So if I run this, right, essentially, you're just going to get your key value pair. So that's an example of integrating a function and dictionary. So in this particular case, this function takes in simple textual information and transforms it into a more meaningful data structure, right? This transformation lets you work with the new information in other ways beyond just printing it. This function can be extended to accept optional values like a middle name, an age, an occupation, and other personal information you want to store. So you can do all of that in this. For example, let's look at this particular example. This particular example allows you to store a person's age as well, not just their first and their last name, right? So we'll say something like, we have already gotten to this point, right? The addition is if age, if you want to include age, right? Just say person age is equals to age, right? This if age just means if you want to include age. right? Just say person, and then you create a particular element, and then you map it to this element, right? And then you return person. At this point, when you return person, it has now included that particular thing too. So what I have here is if age. So I have musician. What do I have? Musician. Let me go back just 1 minute. Musician, build person, just 1 minute. Jim, Hendrik, and let me run this. Jim Hendrik. There's something wrong here. Let me see what is wrong. Okay, I think this is probably it. Yeah. Not exactly. Just 1 minute, 1 minute. If age. Wait, that's not it. That's the error. I think this is supposed to be. Just 1 minute. This is supposed to be on the same line with this. Return age. Okay, I think this is where the problem is. Yeah. This is where the problem is. Yeah, that's it. You see, indentation is really very important. It's very important because when we had it there, it wasn't printing out the age, right? So indentation is really very important. So it just says if this person includes an age, then make sure you're printing out the age. But what if they don't include an age? If there's no age, right? See what it does. It prints out just the first and the last name. But if we decide to include an age, right? Which by the way essentially says if there is age, then print out an age. Then all of a sudden, if you run it, it gives us an age. So in this particular place, all we really did was to include an optional age, to the function definition, right? So we assigned the parameter of none. Look at we included none so that if we're not provided with an age, that's fine. But if this condition is met, then an age, the age is included. So usually you use none when a variable has no specific value assigned to it. So just like what we had in the previous, where we had an empty default, none is essentially a placeholder value. And then you now have the conditional test here, right? Which is true when you include an age, but it evaluates to false if you don't. And when you don't, then there is no problem. You don't have to include age. Thing that a function can do is that it can return any kind of value you need it to, including more complicated data structures like lists and functions. In fact, functions can work with all kinds of data structures. And as it works with those data structures, it's able to return value, that those data structures represent. We're going to be looking at a particular example of um, function, right? Working with a dictionary. In this particular place, the goal is to model a human, like build a person, create a model of a person. But two of the most important things about a person will be their first and their last name, because those are identifiers. So you start with a definition of the function name, and then you throw in those two parameters, right? First name and last name. And then you map those to some kind of dictionary here, where you have first name equals to first colon first name, and then last colon last name. And then that's how you return the person. All right. So this is the particular operation in the body of this function. And then, of course, you're going to do a function call. And in the function call, you have your arguments, your two arguments, and then that's how you map this to this, this to that, positional arguments. Now, when you run this, notice what happens, right? All of a sudden, you have been able to return a dictionary. So that's a specific situation where a function works with a dictionary and returns some kind of value that is a dictionary. And like I mentioned, that can happen with different kinds of data structures that we've already worked with. At some point, I think we're going to also look at us using list to interact with a function. So in this particular case, all that has happened is that it's taken some kind of textual information and transformed it into a dictionary, which is a more meaningful data or more complex data structure, as it were. So this transformation, as it says, lets you work with the new information in other ways beyond just printing them. So, but then I would like us to go look at another situation. And in this particular situation, we want to extend that same function to accept optional values like an age, or I might want to include a middle name, or I would include an occupation or any of those things. So if I wanted to do that, how would that same program change? Notice what is going on here. First of all, the parameter, the last parameter, we had first name and last name before, but now we've added age. But by including none is another way of actually saying false. So this is essentially a placeholder value. In other words, if I eventually decide to enter my parameters, which will be Jim, Hendrik, mapping to first name, last name, this is age. Age is going to map to this. So this is a placeholder. But what happens if I do not provide age, as it were? Guess what happens? This would also will still work. So let me run this first of all. So let's say this person, their age, assuming the age is 100, I run it, I still get my 100. What if I decide to remove this completely and I run it? Notice it's still working. Why does it work? Because this is essentially a placeholder, and by mapping it to none, you're saying it's false. Except I provide an argument here, just ignore it. That's what this particular program is saying. But then this is the particular operation here that actually makes this very possible. It says if age, in other words, if age does exist, was provided, then the person, we would now all of a sudden add one additional element, right, into person. And that additional element is going to be equals to age. And then we return person. By the time person is returning, it now has three elements. 1, 2, 3. But if the answer is no, then this doesn't happen, and then it returns it returns two elements only. So that's what's going on here. So next, we're going to also see how you use function, how function works with the while loop. Now, I've actually kind of commented out all of this because this is a particular situation where we have actually an endless loop. It's an endless loop, and there is no opportunity, as it were, to stop the while loop at some point because the code did not include breaks. So let me quickly give you what that code originally looks like. So if I copy this, it's the same code that you have up here, and I place this. What is this code trying to do? Right? It says you can use functions with all the Python structures you have learned about so far. So that would mean lists, that would be dictionaries, and all of those kind of things. You can use all of them. So for example, let's use the get format name with a while loop to greet users more formally. So we want to greet users, and then we want to now introduce the while statement. So we define the function. This is our function, first name, last name, and then we map this. So we're trying to return this. We're using our f prompt name, first name, last name, and then we're supposed to return the full name and include the title, which is the first letter of that name of the name. The first and last name would be capital, which is what the title font is about. So, but let's come here. So we're saying, please tell me your name. While this is true, as far as this is true, tell me your name. So you enter input. If you remember, input is a function that allows the user to interact with the application or the software. So it says, first of all, first name, and then you enter your first name, last name, and you enter your last name. But notice there's nothing else that stops this from happening. In case it's not true, what's going to happen? Right? So this thing is going to what I get. So it will ask me for my first name. And I say, let's say I say my first name is Tom. Then it will ask for my last name, and I say my last name is Ken, right? It does not stop, it keeps running. It keeps running and running and running. So this becomes one of those indefinite loops that have no end. So what I'm going to do is I'm going to stop this, and let me just go stop this. I would interrupt this kernel. It stops, but then I want to delete it since I've communicated what I wanted to communicate. And then I'm going to go show you the fix for that problem, because you need to have a way of branching off from that program or putting a break on that program if your while is no longer true. So I'm just going to delete this because I still have it here. This is going to keep running. So this is where we come. What we want to do here is to introduce a break. So same code, but notice, first of all, I have my first name and my, for this fellow, we have the first name and the last name, and then it returns the full name. But then while true, same thing that we have here in the previous case, while true, print your name. And then after it does that, then we would also provide some kind of information to the user for what they want to do. Said if you enter Q, that will be a way of breaking that program, right? At any time to quit. So enter Q at any time to quit. So we would now come in here and start with our F name is equals to input. You give me the first name. You say if F name is equivalent or equal to Q, then we break. So anytime I want to break, whether it's in the first name or the last name, I can actually just enter Q, and each time I enter a Q, what happens? The program stops because there's a break here. So let's try to run this program. So now the first name, I'll say Tom, enter. Last name, and I'll say Ken, enter. Then it starts again. First name, but I don't want to, so I type my Q, which is the quit signal. Once I type my Q, then it will break. And that's the end of the program. Notice the program stops. So that message here that you have is the message that tells the user what to do if they want to quit the program. So essentially, the program will continue greeting people until someone enters queue for either name, either the first name or the last name, and that's how the program stops. The next thing that we're going to talk about is in Python here is passing a list. You can actually pass a list to Python. In other words, you can essentially create a parameter, which is what we have here, and then we can pass a list, right? And that list is coming in as an argument. In other words, we can map this list to the parameter, and then that's an example of functions also in this particular case, working with a more complex data structure, which is your list. So how what this does is it actually makes like the list more efficient, because you can just, instead of going through each of the elements, it can completely just map it directly to the parameter. So let's look at this. What's going on here is we have a list of users and we want to print a greeting to each one of them. So this example, right, we'll send the list of this list of persons to the name, and then the printout will happen because we're trying to print out message. So this is the instruction to print, and then this is the print. But then what's going to happen if I have 1,000 people here? It will just map all of these 1,000 to names, send the names for print, and voila, it does. So this is a function that helps you print users in a list very fast. So we start by defining the function. You know, this is your definition, this is your function name, and then we will now want to create some kind of loop for name in names, right? Because once this goes there, then you're going to run through for name in names, message, this is the message I want, hello, and then the name of the person, and title is to convert that to a title case, which is first letter capital and the rest lowercase. So I have a situation like this. So to map this to this is what I do. And if I run this is what you get. Hello, Hannah. So if I decide I can add more names, I can say Tom. I seem to like this name, Tom. We're going to run this. If I run this is what I get, right? Again. So it doesn't matter how long this is, it's going to map to this particular one. And that's our way of passing a list through a function. So the next thing is we can also modify a list in a function. Now, this is a particular case. This is not a function, but this is a regular code that is being written. I'm going to show you how this code works, and then later we're going to make this code more efficient, more organized using a function. And in that particular case, you can actually see how the function helps modify the list and makes it function better. So we start with, so this is a particular case of a company that receives 3D 3D printed models of designs. You know, they send it, and then when they are sent, they will be stored in this list which says unprinted designs. Now, this company or this program takes those designs, prints them, and then stores information here that they've been printed, the completed model. So we take the design, store them in this list, and then transfer them here once it's done. But the way this program is set up, as you will see later, is that it goes in, takes one element, prints out that element, stores it here, takes the second element, and how it does it is it used the dot pop. And once it takes out this element, this place becomes empty, this becomes empty, and this becomes empty. And then how it stores it here is it uses the append method to append it. So which is why it says while unprinted designs. In other words, while we still have something within unprinted designs, then your current design, which is some variable, is going to be equals to unprinted.pop. So once you put .pop, it pops off one element, prints it, and then it appends it. Same here, it now stores it in the completed models .append. That's what it does, and then you print it out, you display all the completed models, you print out this when it's full, and then for the completed model in completed model, each of them, you now print them 1-1. So let's run this and see how it works. See what's happening, right? So it takes the first one, phone case, pendant, and the car drawn. So those are the three of them, and then it prints out everything that you have here. But this is not really very efficient. We can make this program more efficient by reorganizing it. And that's where we come to code reorganization. The first question you ask yourself, what is this program doing? It's doing two things, right? It's collecting the 3D models. That's one function. And then the second function is that it's printing it, right? Which is the completed models. So it's doing those two things. So because it's doing those two things, we can reorganize this program to do two things. In other words, create two different functions that do two different things. One function does the printing of the models, which is the first part, right? And then the second does the completed models, right? So it accepts those unprinted designs, prints it, and then stores the completed models. So those are the two things. But one of the things is that we're actually not going to change the code as it were. It's still the same code that is going to be playing out here. So we'll create two codes. So look at it. The first code does, it simulates the printing, simulates printing each design until none are left. So it accepts and prints them. And then the second thing is it shows all the models that are printed. Those are the two things. So what do? Same thing, we create the function that does that. And then in this case, we put in the two lists, unprinted designs, completed models. While unprinted design is true, while there's something in the unprinted design, then we pop. In other words, we go in there, remove 1-1 from each of them, each element from this, one by one, and then we append it in completed models, right? Then the next thing, now that we have done all of that, the next thing we're going to do is to now go in and print all of this and display them inside the completed model. So you have two functions working together, and this is very efficient. And then this is where we already have our argument, our parameters. This is where you now have your arguments. You can enter any number of, designs here, right? And then the completed model. So all it just does, there's an iteration that is going on. It pops up, dot pop, and then append, moves this to here, prints it, does everything, and then stores it here. Does the same thing with this, with dot pop, prints it, and then stores it here. Does the same thing with this, and then stores it here. And this guy, this particular function, then prints it out. So that's what we have here, print model, and then this is the final printout where it lists everything that has been done. So if you run this, you also get the same thing that we had in that place, but the only difference here is that this is better organized. And then if there is a problem with any of the functionalities, you actually know where to go pick it up and troubleshoot and fix it. And the other thing is I could literally have this stored away somewhere, abstract it, keep it in a completely different area. And each time I want to call this particular model, for example, all I need to do is I will just use this name, print model. Or if I want to call this, I just use show completed model, and then it pulls it for me. Okay, so let's look a bit at the reflections. This example demonstrates the idea that every function should have one specific job, which is what we had there. The first function prints each design, and the second displays the completed models. That's what's happening here. This is more beneficial than using one function to do both jobs. If you're writing a function and notice the function is doing too many different tasks, try to split the function into, I would say, 2 or more functions, right? So depending on what the particular situation is. There are also times when you do not want to, modify a list. So I'll take you back to where we were before. So in this particular instance, when we were working on particular this particular case, this set of functions, um, that's 2 functions. This is 1 function, second function. So the next thing we are going to talk about, is how to prevent a function from modifying a list. Now, to better understand this section, I want to take you back to the previous example that we had before, where we were trying to, move elements within a list around. So in this particular case, we were using 2 specific methods, right, to remove elements from this list and then store them in this list. And those 2 methods were pop, which is popping off each of this one by one. Dot pop pops off, removes each element from this list. And then it now appends it to the next list, which is why you have completed models dot append, and then it begins to transfer it, prints it, and then stores that information here. So that's what's happening. But you know what happens as it pops off each of these elements? This list all of a sudden becomes empty. So the company, as it were, does not have records of these elements anymore. So there are instances where a company actually wants to retain these records. And in that case, instead of completely popping off and transferring elements somewhere, right? You just want to copy each of the elements into the new list and having the original still available there. And there's a way to do that. And the way you do that is by introducing this. Now, look at these two statements, right? This here is a comment. So focus on this. Now compare this with this. The only additional thing I've done there is to include this square brackets and a colon in between. By just implementing this here, all of a sudden, you would be able to transfer elements from this into this and still retain the values that are here. So that's what it takes to prevent an element. And you can see it here. I said the slice notation, which is this square brackets, and then the slice notation, which is the colon, makes a copy of the list to send to the function. If we don't want to empty the list of unprinted designs, right, we could call print models like this. So this is the way you call the print model. And that way, you have a copy. Now the function print model can do its work because it still receives the names of all the unprinted designs. So that's why it can do that. And print models is referring to the first function, right? Which is this. It can still do its work. Why? Because it's still going to receive the unprinted designs. So I'll go back to it. It's able to do that. But this time it uses a copy of the original unprinted design list, not the actual unprinted design list. So it uses a copy. Now the list, which is the completed model, right? The second list will fill up with the names of printed models like it did before, but the original list of unprinted designs will be unaffected by that function. So that's what's happening there. But these reflections are also very important, and I'm going to talk about it. Even though you can preserve the content of a list by passing a copy of it to your functions, you should pass the original list to the functions unless you have a specific reason to pass a copy. In other words, use the original, write the code the original way, only try to store a copy, right? Which is what this helps you do. You only do that when there is a really important reason why you want to store that data. And this is particularly important because we have a small list right now, but then there are instances where you have a large list, a list that could literally include, maybe hundreds of elements. In that particular case, you will be creating a lot of problem for yourself. Let's go back. So it's more efficient for a function to work with an existing list to avoid using the time and memory needed to make a separate copy. So in terms of the time and the memory, right, it's better for you to just go use that, except there's a compelling need for you to store that data. And it says this is especially true when you are working with large data sets. So that would be how you deal with that. The other thing I'm going to talk about is passing an arbitrary number of arguments. How do you pass an arbitrary number of arguments, right? So look at this function. In this particular example, there are times when you want to build a pizza, right? Let's say you've written this code about building a pizza, and people are obviously going to ask for toppings. Maybe let's say you have 10 different toppings, but you don't know how many toppings your customers might ask for. It might be one topping, it might be no topping, it might be 9 toppings, it might be 8 toppings. Now, if my argument, right, has to match my parameters, then I run into some kind of problem. And that's why there is a workaround for this. So for a particular case like that, you don't know ahead, of time how many toppings that person will want. So what we're going to do in this particular example is to show how you can literally do a parameter like this, right? You can see this toppings, you have this asterisk toppings. So it says, notice that the parameter is asterisk and toppings. So that's what you have. So we've created this function. We want to print out the toppings. And then we said make pizza. So this is one function call. This is a second function call. Let's say the first person came and said, hey, I just want only one topping. Another person comes and says, I want 3 toppings. How do you map all of this to this? And the way you do it is you just include the asterisk before the term that you're using here. If you run that, you can see this gives you pepperoni and then gives you this. I can decide to add more items here, right? Let's say I add more items here. And then I go and I say pineapple. Pineapple is a topping, by the way, right? And then I look for something like beef, right? Another topping. If I run it, right? These are 3 different customers, right? Asking for different number of toppings. If I run it, I also get the same thing. Why is this possible? Is because of the dot or asterisk and then the toppings. Now notice the asterisk in the parameter name tells Python to make an empty tuple called toppings and pack whatever value it receives into that tuple, which is irrespective of the number of values it receives, in other words, number of arguments, right? Just pack everything into that tuple. And remember your tuple is, you have your parentheses. So the print call in the function body produces output showing that Python can handle all of this, right? So it treats the different calls differently, right? Whether it's one topping that is requested, 3 toppings, or any number of toppings that's requested. So the next thing we are going to do is, let's look at this too. So let me run this and let me see how it goes. So look at this. We have same thing here, toppings. So no matter the number of arguments, this whole thing works, right? We can now go and we say for toppings, in topping, and then you print this out and then you get the same thing, same thing. So the next thing we'll talk about is mixing positional and arbitrary arguments. How does that work? Now, if you want a function to accept several different kinds of arguments, right? Which is your arguments, several different kinds of arguments. So you can see here it's a number, a string, or an integer, a string. So if you want it to accept several different kinds of argument, the parameter that accepts an arbitrary number of arguments must be placed last in the definition function, right? So in that particular example we had, this is the parameter that was open and able to receive random number of arguments. So what you do is you try to place that to the far end, and then the other positional argument, you can place that inside, right? So this is a particular case. So in this particular example, what we are trying to do is to decide or include the size of the pizza. So you have the size of the pizza, you have the toppings, right? If you run this, what you're going to see is the size, and the toppings. So this is a way of mixing your positional and arbitrary arguments. So this is your positional argument here, and this is your arbitrary argument. If you had to mix both of those, the rule is you place your positional argument inside and then your arbitrary argument will be out. And when you run it, you get, the results that you're looking for. So sometimes you want to accept an arbitrary number of arguments, but you won't know, ahead of time what type of information will be pasted on the function. And in those specific situations, what do you do? So let's look at a particular example. So in one example involves building user profiles. So when you're going to do your user profiles, a user profile, at least one of those things you're going to know is that you're going to know there is probably a first name and a last name. But you also want to make it possible that it will accept an arbitrary number of key word, kind of key value pairs, right? So keyword arguments. So this is what's done here. You have your first name, which you're sure you are going to have, your last name, and then you use the user info. And notice what you put here is your double asterisk, right? With your double asterisk, watch what happens. Your user info, you'll be like, you can map that to your first name, it will give you first. Last name, it will give you last. And then return this value. So now you have first and last name guaranteed. Then to add additional information, that's where you can use your key value pairs, where you still use your you use user profile as your variable equals to build profile. Remember your build profile, and then you can include whatever it is that you want here, right? And it would easily, you know, be added to the first, last name, and whatever it is. So it's going to start with here, the argument for first name will be this, last name will be this, and then you can add any number of things. For example, I can add country. So country, I can say something like country equals to USA. Let me be consistent. So all I need to do is I will say, sorry, and then I would run this, right? Notice it gives me the first name, last name, and every other thing, country, field, physics, location, Princeton. So that's how you deal with a situation like that. So on and on and on. So Python, you just need to be, you need to practice, and you need to, watch other people code. There are any number of ways that you can use a function to solve all kinds of problems. And some of these would naturally come to you by experience. So I'll talk to you in the next video.